Looking at the centripetal acceleration homework on page 226, 1 through 4. So, on number 1, we have a child on a swing. The swing has a rope length of 2.1 meters. They give us the centripetal acceleration of 3 meters per square second. What is the tangential velocity? The question to ask yourself is, when you're looking at a generic swing, is the length that they're reporting, is that length your radius? Well, if a swing is, of course, swinging through a motion like this, right? Sorry for the crooked line, but you get what I'm saying. As a swing swings through, yes, the length of the rope is the radius. So to solve this, we are going to take our 3 meters per square second, VT squared, over r. So I think in order to solve that, I'm going to have to multiply the r over. So I'm going to have 3 meters per square second. I'm going to have to multiply that then, multiply by the 2.1 meters, that is the rope, and that's going to equal VT squared. Of course, squared. So 3 times 2.1, well, that's 6.3. 6.3 equals VT squared. So 6.3 equals VT squared. And then it looks like we just got to do a square root to find out the answer to this one. And when you square root that, you are left with 2.5 meters per second. Understand, of course, that I'm looking at the book's rounded numbers if yours are slightly different. Okay, make sure that if you need to pause the recording to go over something, you do so. Alright, moving on to number 2. In this problem, a young boy swings a yo-yo over his head. The centripetal acceleration of the yo-yo is 250 meters per square second. If the yo-yo string is half a meter long, what is the yo-yo's tangential speed? Well, now we're looking more like something like the Death Star here in the picture. And the string in this case is representative. There's the center. Out here would be where the yo-yo is. The string does represent the radius in this case. So the setup is exactly the same as it was in the previous question. So our centripetal acceleration moves to 250. The radius, again, we're going to multiply the radius over. So the radius of 0.5 meters goes there, equals VT squared. So 250 times a half, well, that's 125. 125 meters per square second is equal to VT squared, and then we have to square root 125. And when we square root 125, I'm getting an answer of about 11.2. 11.2 meters per second is the tangential velocity of the yo-yo. Alright, we're going to move on to number 3. Number 3. Here, I've apparently labeled too many things. In number 3, a dog sits 1.5 meters from the center of a merry-go-round. The merry-go-round is a tangential speed of 1.5 meters per second. The centripetal acceleration is our unknown. My apologies. The centripetal acceleration is our unknown, so now we need to solve for that this time instead. So this work that I have sitting down here is totally invalid. That's not what I want. This stuff's totally worthless. Well, now we need to do the equation as it appears, where it is tangential velocity squared over the radius. So this is going to work out very nicely for us. So if you follow what I'm saying, tangential velocity squared, so 1.5 meters per second, and squaring is multiplied by what just happened while I wasn't looking? Sorry. The microphone was pushing down a key on the board. So 1.5 meters per second times 1.5 meters per second, because that's VT squared. And then we're going to divide that by the radius of 1.5 meters. Well, that divide sign looks a little worthless, so let's just take a line here and make that into a divide for us so it looks pretty. Come down here. And all of a sudden, a swing becomes a division symbol. There we go. How nice is that? And if you learned a couple things during math class, you would say, oh, 1.5 divided by 1.5, that doesn't matter. Therefore, the tangential velocity, or I'm sorry, the centripetal acceleration in problem number 3 will be 1.5, the meters cancel, meters per second, which is meters per square second. That is our unit. 1.5 is the answer. All right. And last, but certainly not the least, would be number 4. Now, number 4, we do not have the radius. We have a racetrack here. A race car moves along a circular track, has a centripetal acceleration of 15.4 meters per square second. If the car has a tangential speed of 30 meters per second, what is the radius of the track? Oh, yeah, it's a racetrack. So we set this up, and we have to say, let's see, 15.4 meters per square second, that's our acceleration, is going to equal the tangential speed squared over the radius. So we gotta do a little math on this one before, a little more complex math on it. 30 squared, that seems in my head to be about 900. So this is actually about 900, if I'm not mistaken. So let's kind of drag this out of the way. Drag this out of the way. Right? So about 900 divided by r is equal to 15.4. It looks like I'm going to have to multiply my r over and divide my 15.4 over. And if you haven't calculated this already, you should turn on your handy dandy calculator and calculate it. See, handy dandy calculator. 900 divided by 15.4. If you can read those tiny numbers, they say 58.4, and that parallels what the book says, 58.4 meters wide, 58.4 meters wide from the center of the car to the track. So there's your tangential velocity homework and there's centripetal acceleration homework.